I'm Nam, and I'm working on this final project with my friend Kenneth, and we're exploring if there are any auto locks is better in Mutex. So to find out, we're exploring four different locks, and we implement them from scratch. And we have defined a different tester to test auto locks under a different scenario to see how they perform. So uh, so for roughly the four locks that we look into is the ticket lock, which is for really enforce fairness, FIFA fairness, and then we have like the reader writer lock, which has reader writer lock, which is actually more for parallel reads, and the sequential lock is more into optimistic lock, and then we have the MCS clock. So you can imagine MCS clock is more into like a queue-based clock and actually help prevent cache contention. So next is that like let's have a look at the result of the test that we have run to see how it goes. So for the first three tests, we can clearly see that the sequential lock really clearly the winner here because like we can clearly see that the sequential lock like the readers they don't really have to write to the memory, so there's zero bus traffic, so which is why they're so fast and they have like around like 10 to 13 million operations on these tests. So clearly we can see that that's really triple of what the mutex currently have. So but at the same time we can clearly see that the tick lock is actually falling far behind compared to other locks. So the reason why is the tick lock like they enforce fairness and they're actually forcing every thread into a single file line, so which is why they destroy parallelism and like work not efficient as others. Now let's moving on to test 4 and test 6. So for test 4 and test 6 is more of like write dominant test. So more riders here, and we can clearly see that reader rider locks win here. So the reason why is the reader rider lock we implement is more into the rider prefer, and which is why the riders that will essentially block every new readers coming on. So which is why it's been working more efficiently here. And again, we also noticed that the mutex slot, even though there's not the winner, but like there's still hold strong and still in the top here. So clearly, again, throughout the test so far, we can see that the mutex performed pretty well. Now let's moving on to the test fly where we perform stress tests. So for the stress test, we are performing like 16 thread on our 8 cores. So you can say that it's like an oversubscription, essentially. So we can clearly see in this case that the MCS cloud and the tick cloud is actually falling behind again, and they actually dropped to a couple of hundred thousand, like a couple of hundred thousand operations per second only. So the reason why is ticket lock and MCS clock they're both spin lock, so which is why like I mean like compared to auto locks like mutex then for the spin lock then when like the os actually like sleep the lock holder then everyone else and every other that just like like burn the cpu and just spinning and doing nothing. But then for the mutex they will actually put them on to sleep, so which is why you can see that the mutex performs really good here but the ticket and mcs fall behind. Now, let's move on to our last test. Is the test 7, where we test for slow critical section. So for the slow critical section test, we can clearly see that Mutex again performed really well, but then again, Ticket and MCS actually formed behind one more time. And it clearly shows us that for a longer time, spin task seems to spin locks seems to perform not as efficient as auto locks, and the reason is the same. Where we actually it will say just waste CPU based on just for like like spinning and doing nothing, whereas like the mutex will actually like enforce sleeping or and it will actually save more time for that. So for all of these sets we have been looking so far, we can clearly see that like the sequential lock the sequential lock will work very well for under read heavy scenarios, and for the reader and writer lock with the writer prefer implementation, then it will actually wins under like write heavy scenarios. And then like we have like we can also see one thing that like the spin lock is not really good for like longer tasks. Like when we have longer tasks that spin lock, there will be cases where it actually like if they always click the lock holder, then like we just they'll order everyone else will actually like burn the CPU and like spinning and doing nothing. So, but in Mutex throughout all the tests, it actually performed really good and actually the safest option so far because like we can see that it handles scheduling very well. And even though it's not always like the top one, the winner of all the tests, is actually like perform very well under like different scenarios. So yep, that's one of our conclusions we have been got throughout this test and our final project. So thank you for listening.